Assalamualaikum and hello everyone. Welcome to the video for 3.1 Galvanic cell. In this video, we will learn to use the standard reduction or the electrode potential to compare the relative strength of oxidizing and the reducing agent and predict the spontaneity of a redox reaction. On your notes, you'll be on page 6. Okay, so to compare the strength of the reducing and oxidizing agent, we will compare it based upon the SRP value or the E0 value which is given in the question. Okay, just for you to remember, reducing agent is the species where it undergo oxidation, but oxidizing agent is the species where we undergo reduction. It's the other way round. Okay, so here let's look. Okay, the higher or the more positive the value of the E0. Okay, so just to remind you, the more positive the value, remember because positive, it is cathode. Just to remind you, T here, T pun here. So positive is the one with cathode. And we know at cathode, reduction occur where the reduction is gaining electron. So here I'm just going to write down gain pula. Reduction where we will gain electron. Okay, so here, the more positive the value of the E0, the easier it is for the ion to undergo reduction. So when it undergo reduction, actually it is a more stronger oxidizing agent. Okay, it's the other way around. Okay, the stronger the oxidizing agent, it is actually the more positive value of E0 cell upon E0 value. Okay, next, the lower or more negative the value of E0. Okay, this one. So for the negative one, because negative and the negative is actually negative our N here. Remember it is our anode. Okay, the more negative is actually referred to be at the anode, and then anode is actually where oxidation occur, where it will lose electron. So here I'm just going to write down anode, oxidation, lose electron. Okay, so here, the more negative the value of E0, the easier it is for the ion to undergo oxidation. But if it undergo oxidation, so it means that it is a stronger reducing agent. Okay, so here it means that the stronger the reducing agent, the more negative the E0 value. Okay, so that's the information that you have to know. Okay, next let's look at the question. So first, arrange the element in the order of increasing strength of the reducing agent. So for the reducing agent, we know that the species is actually undergoes oxidation. Oxidation, oil, it is lose electron. Okay, so when we're talking about the elements, first we have to distinguish which one of the species is the one that will lose electron. Is it on the reactant side here or on the product side here? Okay, when we look here, all on the reactant side is gaining electron. So this is not the species that undergo oxidation. So which one of the species that undergo oxidation is this one? Because actually, when we swap it around, we will get the equation to be losing the electron. So here is the species that undergo reduction. So it means this one is the species that undergoes oxidation. So when we arrange the element, make sure we arrange all the solids here, not all the aqueous. Okay, and then for the oxidation, for the reducing agent, here it mentioned that the stronger the reducing agent, the more negative the E0 value. So here I'm just going to write down the more negative E0. So it means we have a stronger reducing agent. So from here, we have to arrange in the order of increasing strength of reducing agent. So it means that from the weakest to the strongest. So it means that from the least negative to the most negative. Okay, so from this value, as we can see, we only have one negative value, so it means this is the strongest one. So I'm just going to write down here is as number 1. So it means that it's the strongest. Okay, so second strongest, okay, the one with the more negative value, if we compare these two, it's actually this one is more negative compared to 0.8. Okay, the more negative because the value is nearer to 0. Okay, so now let's arrange it in the order of increasing strength. So start from the weakest. Okay, and we have labeled our silver as the weakest one. So silver is the weakest one. Okay, the next strong one, but not the strongest one. Okay, the second one is actually our copper solid, and the strongest one is actually nickel solid. So when we arrange the element in order of increasing strength of the reducing agent, it's fine if you want to arrange it like this, or you could also arrange it as this one, and then you just have to write down an arrow down here, and then just mention increasing strength of the reducing agent. Okay, so I prefer to write it down like this because sometimes when you use the symbol here, it meant differently lah. Because when you meant it like this, it means this is the strongest one. Okay, and then if this is the symbol also, this is the correct one. So it means that the nickel is the strongest, the copper is the second strongest. So that's why I didn't prefer to write down the symbol. It's fine if you write down comma, and then you're just going to write down an arrow down here, and then mention that this is the increasing strength of reducing agent. So that is actually for example A. Okay, next we're going to look together is example B. Okay, so arrange the element in order of increasing strength of oxidizing agent. Okay, still increasing strength, but first let's look. Oxidizing agent is the process where the species undergo reduction, and reduction is the process where gain electron. Okay, so reduction is which species? Okay, this is actually the species that undergo reduction, because all of this gain electron, right? Okay, so here is my species, the species that we are interested in. So next, for the increasing strength of oxidizing agent, here we have written down the stronger oxidizing agent, the more positive E0 value. So more positive E0, so stronger oxidizing agent. Okay, so let's arrange it from the strongest to the weakest. Okay, so number 1, the strongest one must be the most positive. So the most positive one, okay, the one is the most positive here. The strongest one is this one. Okay, the second strongest, okay, we do have 2 negative value. But which one of the value is nearer to the positive? It's actually this one. So here is number 2. Then here is number 3. So next we have to arrange it. Remember, in order of increasing strength, we're talking about the species here. Write down the state as well. So we're going to start from the weak to the strong one. So we're going to start with Y2 plus. Okay, the next one is actually X3 plus. And the strongest one is actually the L2 plus. So it's fine if you're just going to leave it like that. Or you could also add in the arrow just as previously I have written down. Just going to write down arrow, and then we will write down increasing strength of oxidizing agent. So that is actually for example A and B. Example C and D, okay, I will include it in the Google form. But for example C here it mentioned decreasing. So make sure decreasing, it means we have to arrange from the strongest to the weakest one. The same goes here, decreasing strength. Okay, so that is about comparing the reducing and oxidizing agent. The last one is actually to predict the spontaneity of a redox reaction. Okay, so how to predict the spontaneity is that we will still use the E0 cell is equal to E0 cathode minus E0 anode. It's just that, okay, that's why it is important for you when you calculate the E0, you have to include the positive or the negative sign. So spontaneous when E naught cell is positive, non-spontaneous when E naught cell is negative, and at equilibrium when E naught cell is equal to 0. Okay, so again, how to know which one is cathode, which one is anode? Here, the anode, oxidation occur, it must be the more negative value. More positive value is for the reduction process which occur at cathode. Okay, so here I'm just going to write down for the example A here. So here we have an equation and here is the E naught value. So how to know which one the anode, which one is cathode? Okay, you don't have to be confused with this equation. Just look based upon your E naught value. Okay, so again, cathode more positive, anode more negative. So which one is which? The more positive one is this one. So here is my cathode and here is my anode. So actually we can calculate it straight away. Okay, so we can substitute this value into this one into this one. And then once you have determined the value, because we want to predict the spontaneity of the redox reaction, so since it is a positive, so we have to write down this is a spontaneous reaction. Okay, spontaneous reaction, it means that this reaction will occur. If the non-spontaneous, when the E naught value is negative, so it means that the reaction could not occur lah. Okay, so that's it for the example here. Example B and C, I believe you could try yourself. So that's it for this video.